In this video, we're going to do parametrics with the second derivative, and obviously the second derivative is the derivative of the first derivative with respect to x. In parametric, that would be the derivative of the derivative over dx dt. The derivative of the first derivative on top, previous denominator on the bottom. Let's go ahead and do an example. So I want to start by finding the first derivative, dy dt, over dx dt. Well, dy dt, derivative of 2t squared would be 4t, and derivative of 4t cubed would be 12t squared. At this moment, I'm going to go ahead and copy that previous denominator down to my second derivative so that I don't forget dx dt goes on the bottom. Reduce this, I'm going to get 1 over 3t, which is the same thing as 1/3 t to the negative 1. When I take the derivative of that, that's going to be negative 1/3 t to the negative 2, or negative 1 over 3t squared. Well, let's think of the bottom as a fraction, and let's multiply by the reciprocal. Negative 1 over 3t squared times the reciprocal 1 over 12t squared gives us negative 1 over 36t to the fourth as our second derivative. Example 2. I'm going to start again with the first derivative, dy dt over dx dt. So looking at this problem, derivative of 3t to the fourth would be 12t cubed. Derivative of 5t squared would be 10t. I'm going to go ahead and at this moment copy down that previous denominator before I reduce it, because that is dx dt, and dx dt goes to the bottom. Now I'm going to reduce this, so it looks to me like I have a 6t squared over 5. So 6/5 t squared over 5. Derivative of that would be 12t over 5. Think of this like a fraction. We're going to multiply those reciprocals, so 12t over 5 times 1 over 10t. Well, we can do a little reducing. The t's go away. 5 and 6. Our second derivative is 6 over 25.